Good afternoon, everyone. So we all write about quantum physics, and we've done it lots of times. So we've maybe perhaps have lost the thrill of encountering quantum mechanics for the first time. So my first question to my panelists is, where were you and what was your reaction when you first encountered quantum mechanics? So, Nicole?
As far as I can recall, I first encountered quantum mechanics as a junior in high school. I encountered it simultaneously in two courses. One was chemistry, and there was a very plug-and-chug attitude. Here is the uncertainty relation, plug into one side and calculate something, or here are the rules according to which electrons are distributed in atoms, apply these rules to this element. I was interested in everything, so I was interested in these rules, but simultaneously I had a metaphysics teacher who knew very little about modern physics, even he would say, but he was fascinated by it. So he gave me some information that was not completely correct, but he really sparked my curiosity. And it's in large part because of that I turned to the physics department in college.
Yeah, like Nicole, I encountered quantum physics first in high school as a senior in AP Physics. My physics teacher liked to just give us additional reading, and she had us read a book called The Dancing Wu Li Masters by Gary Zukav, which is one of those books. I guess the Tao of Physics is the more well-known one, and I read that book voraciously, and there's just so much enthusiasm about physics, and I've come to learn that maybe there were some things that are inaccurate about it, but just the enthusiasm and excitement about quantum physics sort of reinforced my desire to major in physics. And then, shortly after I read the Feynman lectures, I guess volume 3, the first chapter, great treatment of wave interference. And by the time I was a senior in college, even learning the Schrodinger equation, my interest in quantum physics only deepened as my understanding matured.
Yeah, well, similarly, I think there's a lot of commonalities between our stories. I was also in high school. I was taking a AP Physics class with an amazing teacher. I also grew up near Brookhaven National Lab, so I had some exposure to physics there. But interestingly, that is not where I was first exposed to quantum mechanics. It was in a Broadway play. I went to see the play Copenhagen by Michael Frayn, and that's a story about Heisenberg going to visit Bohr in Copenhagen, and sort of hypotheticals about what those conversations involved. And during that production, they explain Heisenberg uncertainty principle, which I had never heard of before. And the ideas there really fascinated me, brought them back to my high school physics teacher, tried to understand those ideas some more with him, and then got into reading other books about physics, so Stephen Hawking, A Brief History of Time, and George Gama's Mr. Tompkins, where there's sort of this character who falls asleep and has a dream, and then he's living in this quantum world where all the quantum effects are visible in daily life. And so there's I think we're all sort of describing how we had these depictions of quantum that weren't necessarily fully scientific, but really sparked a lot of imagination and curiosity. And so yeah, that's where I came to it from.
Thank you. My story is much more boring. I was an undergraduate and quantum mechanics was a required topic. But what struck me was how powerful it is. Without quantum mechanics, you can't solve things like the energy levels of hydrogen or other atoms, or you can't even figure out why a metal is a conductor. So now for our first real question, about communication. So Ben, earlier this year, NIST, where you work, announced a record-breaking atomic clock. So how do you and your colleagues approach writing press releases for these kinds of achievements?
Sure. So at NIST, we've actually been building atomic clocks for more than 75 years. And yet there seem to be constant advances and innovations in atomic clocks to this day. And we could probably write many press releases about atomic clocks per year. But we look in particular for milestones that might excite the public, or science may interest science reporters like Emily, like new records for accuracy or stability. So, or like a, important paper on the topic. So actually the story that Charles is referring to was a new accuracy record in quantum logic clocks, which is one of the, many types of atomic clocks. And we hadn't actually done a news story on logic clocks for several years. And I think we wanted to remind our readers about this type of clock, which may have very good applications, in addition to like the lattice clocks that are out there, and of course the fountain clocks, which are currently used to define the second. But I thought I was very enthusiastic about writing it because it was definitely just a milestone, a new record, but an occasion to remind people about the quantum logic clocks and sort of mention what's happened over the last few years in that. In terms of our audiences, it would be like science reporters like Emily, who might cover physics, the tax-paying American public. And we also try to make our pieces have enough background and define the jargon so that everybody who's interested in it can get something out of it, whether it's a science-interested layperson or someone in the field. Now, news releases are kind of one-shot deals, and they're snapshots in time. Records are constantly being made in atomic clocks. So what we do, we complement our news releases with sort of more big picture explainers on the NIST website. One of my colleagues wrote an entire website on the history of atomic clocks, different types of atomic clocks. So that way we try to provide background to our readers for that. But in terms of covering a topic like atomic clocks, it's basically looking for milestones. It's an occasion to cover an important topic and to bring people up to date on what we're doing.
Right, my next question is for Emily, and it's based on a really nice feature article that I read that Emily wrote. And it included some Q&As with 5 physicists who are doing cutting-edge quantum research. So this is really tough stuff. But when I saw it on my screen, it was quite clear that the physicists were talking at a really accessible level. So Emily, how did you get them to talk normal?
Yeah, I think that, so in the crafting of an article, whether it's a Q&A or a more normally sort of like a piece where I write and quote scientists, there's sort of like 3 stages, I think, where I'm trying to make it more accessible. So the first is when I'm interviewing the scientist. Before we have the conversation, I kind of we'll try to prepare them for, where I'm coming from, where my readers are coming from. So I'll often say, I write for Science News. Our audience is general audience, people who are interested in science but don't have a background in it. I will also sometimes note that our magazine, we have a program where our magazine is mailed to high school students, and I think that often gets people on the right page. Scientists tend to talk above the level that is actually realistic. So they will, if you tell them to talk for a high school student, they might talk for a college-educated person. But I can sort of work with that. Also tell people to keep their answers short. In most cases, that can help prevent kind of like deep dives into jargon. And then, during the interview, I'll do a lot of like backing up and asking people to explain if there's a phrase that's unfamiliar that my readers won't know. I ask them to rephrase it, to use different language. Asking a lot of clarifying questions. Often asking questions that are non-scientific can get people in the right frame of mind. So asking a question about like, how did you feel when you made this discovery, or how, what was the experience in the lab, working late hours, like what was that like? Those kinds of questions can kind of help people loosen up a little bit. Then I would say the last phase of writing an article, and even in a Q&A like this one, we shorten it and kind of edit it a little bit, it's the editing phase or the writing phase. So where I'm looking through what I've spoken to the scientist about. If it's a Q&A, I'm kind of finding the questions and answers that are the most coherent and understandable. And just trying to keep myself in the perspective of a reader who may be a high school student, or maybe someone who is a reader who loves biology but is terrified of quantum physics, or doesn't know anything about science. So just trying to keep that in mind, and which sort of descriptions that the scientists have used is most accessible to those people, and doing a lot of picking and choosing. So yeah, that's kind of my process.
Oh, thanks, Emily. It never occurred to me to ask a human question to physicists, so I'll do that from now on. So Nicole, you wrote an award-winning book called Quantum Steampunk that tells readers how quantum physics is transforming thermodynamics. But a book just doesn't happen out of the blue, and in the process of starting from proposal, through writing, through editing and promotion, what did you learn about communicating quantum?
I had a couple of takeaways that were my primary takeaways. One was it's useful to talk in terms of what I call the basic physics. And some physicists actually know this language. I did my PhD at Caltech under the tutelage of John Preskill. He's renowned for speaking in terms of the basic physics. But this is the language that he would give us when we were having lunch together, and he'd be doing something like explaining the latest discovery by LIGO in terms of gravitational waves. Experimentalists would do this a lot too. They would know their material so thoroughly that they didn't have to throw a lot of equations at us. They knew what was essential, and they could tell a story. So they would tell a story about some particles that are maybe moving around, maybe influencing each other, and they would speak in terms of actions like preparing systems, transforming systems, measuring systems, getting outcomes. These are actions. They involve characters. They involve people in a lab. They involve particles. So I learned, I feel at Caltech, in large part from the faculty around me, to speak in terms of the basic physics. Then throughout my PhD, and in fact until this day, I've been writing once a month for the blog Quantum Frontiers, which is the blog of Caltech's Institute for Quantum Information and Matter. John would read my blog post. He still reads my blog post every single month. So that has been inspiration to me to focus on the basic physics, and that's what I tried to focus on in the book. My second takeaway has been, it is really useful to have already prepared the answers to a number of questions that you can get again and again in, say, the question and answer session of a public lecture where you are, say, promoting a book. So I get questions, what is quantum mechanics? What is quantum information science? What is quantum thermodynamics, one of my fields of research? What is entanglement? And having stock answers that I can pull out quickly and easily is helpful for a lot of people.
Right, so Nicole's a researcher, so when she has a hot result, she'll contact someone like Ben. So how do you work with someone like Ben to make sure that reporters like Emily and me, we know about your research, and that how do you make it work to craft a press release that is accurate but also exciting?
I've really appreciated interacting with science communicators, including both people on stage here with me and to my left. I find it to be a really productive back and forth process. But suppose that I have an exciting paper that's going to be published soon, sometimes a science communicator will come to me and say, I'm interested in writing an article about this. If I'm about to publish a paper in a journal like Nature Physics, I might reach out to my home institution science communication team. They'll read the paper and then, as Emily pointed out, come to me and say, here's my background, we need to have a conversation. Then we have a conversation. Usually it's recorded by the person who's going to be doing the writing so that they can refer back to quotes and refer back to the recording for details. They'll write a draft and send it to me. Then we go back and forth about the draft some number of times. I often leave comments saying something like, this is almost correct, maybe we can tweak it a little bit this way so that it's more representative of what's really going on. And I find that writers tend to be very receptive to this back and forth. And when I have the opportunity to participate in it with science journalists and other science communicators, then I tend to be very happy about the outcome and its level of accuracy.
So the next question is for Ben. So in your job, you're obliged to monitor mainstream media, and you've been doing it for a long time. So what trends have you noticed over the past few years, maybe past decade, about how mainstream outlets like the NPR and New York Times cover physics and quantum physics?
Yeah, so I'm the managing editor, so I used to be in media relations more directly, but I still follow the clips. And I mean, I've found with resources being more limited in the journalism world, a lot of outlets, not Science News, not NPR, not the main, like not Wall Street Journal, but a lot of outlets will simply copy and paste our news releases. And that makes it all the more important for us to make sure it's accurate and accessible. I mean, I have found that, I mean, I generally think that a lot of the quantum coverage is good. I think that, you know, for first-timers learning about the field, there's a lot of good information out there, like post-quantum cryptography, et cetera. I mean, I think that quantum computing being a very exciting field that's been getting a lot of coverage. I think we might talk about hype and overhype in a little bit, but it's still very positive. But yeah, I mean, generally those are two things, just copy and pasting of our releases. And I think for those that are still doing original articles about quantum, it's getting better and better as reporters are getting more familiar with quantum.
So Emily, part of your job is to write about the latest in quantum physics. So how do you pay attention to all this research, and how do you learn about quantum physics to stay, you know, current?
Yeah, I mean, a combination of sources. You know, I keep track of press releases that people like Ben send out. I am looking at all the journals. I'm looking at other publications like physics, other, you know, other popular science publications and mainstream news outlets as well. And just keeping tabs on all of that. And then I also try to keep good relationships with scientists who I've spoken with previously, and encourage them to send me interesting papers that they have coming out. And sometimes get tips that way. Going to scientific meetings and conferences as well is another good way to keep your finger on the pulse of what's happening with quantum. Yeah, so.
So I have to admit, because I'm so immersed in physics as my day job, I don't read any physics for fun. But so starting with you, Nicole, do you read popularizations of science, maybe in biology or some other fields, or you like me? I do it for a living, and I want to do other things for fun.
So my sources of physics news are mostly papers and venues for physicists, although nowadays a lot of that is happening on LinkedIn. So my social media engagement is nowadays in large part for physics purposes.
Yeah, yes, you're a good poster on LinkedIn, and I've also noticed other physicists sort of joining up in professional conversations on LinkedIn or telling people about their new research. So Ben, do you follow social media as part of your job?
Sometimes social media, sometimes YouTube, but actually I read like Emily's articles to stay on top of a topic. You know, of course, I'm very aware of what's going on at NIST, but to get like the larger view of what's going on in physics, like Physics Today, Physics World, APS Physics are kind of my bread and butter in keeping, you know, on top of things. And personally, just as a person, I enjoy Veritasium, for example, on YouTube. It's very, like, that's an interesting thing, is that there are very deep dives on physics topics for interested people that are very accessible, yet very deep, and you don't have to be a physicist to understand. So I focus on the good stuff that's out there, and there is a lot.
And Emily, do you watch YouTube videos on the berry phase, for example?
On the what?
Berry phase. This is a subtle quantum mechanical effect, and I remember it long enough to write a story, and then I completely forget about it and have to look at another YouTube video to remind me what it is.
Okay, yes, yeah, I didn't hear what you said.
Yeah.
Let's see, I don't know if I usually go to, I think usually I would go to the scientists and ask them. Sometimes I'll look for other sources. I mean, YouTube, I also have perused Veritasium at times. I used to enjoy watching the Physics Girl YouTube channel, but she is taking a hiatus because of long COVID. She's a very severe case of long COVID. But there's other, YouTube is a good source. Also, this is more of a fun source, but you can go to TikTok and scroll through some lighthearted physics videos to kind of keep up with what people are talking about.
All right, so the next question is actually to do with quantum computing. So Nicole, you're at a party, you're the only physicist as far as you know, and someone comes up to you and says, should I invest in quantum computing? What is it?
No one has actually asked me that at a cocktail physics party. Maybe I would say, if you want, I can tell you something about quantum computing, but it's not for me to advise you about your money. Different profession.
What about you, Ben? When you're among civilians at a party, what?
Yeah, so what's actually very interesting is that there are a lot of people that have heard of quantum and are very excited about it, and sometimes they have misconceptions, like maybe new agey, misconceptions that, look, I have this crystal, this quantum crystal, and you maybe point out to them, well, like a chunk of cheese has more energy than that crystal, and it's sort of a entry point to sort of talk about, quantum as I've learned about it. So, I like to talk about a lot of topics, but if someone's really interested, I will definitely engage them and try to meet where they are on a topic.
Do you find that too, Emily, when you're among civilians?
I think when someone comes to me with maybe a misunderstanding of quantum physics, but they're excited about it, I want to encourage that excitement. It's sort of always a question of, and I think this goes back to what we were talking about with the answer to the first question of how do you encourage that curiosity and wonder without squashing somebody's incorrect assumptions of what quantum means and what it is and what it can do. So I always try to kind of go back to real science and the things that are actually really cool about quantum physics and just have a deep conversation with somebody about how the world, how fascinating it is that the world works so differently on quantum scales than it does in our everyday existence. To me, that's really fascinating, and that there's still things that we're learning every day and trying to understand about the world and how it works on this level. Is still, I think that is really curiosity provoking. So.
And do you get a sense that people fully appreciate how important quantum is?
No, I don't think people really do understand that. I mean, I think that people don't, that hasn't been fully grasped by people yet. So, you can pull out your cell phone and talk about the different components of your cell phone and how quantum physics is important for the technologies behind all the different components in your phone and that kind of thing. But yeah, I think, no, I don't think people have fully grasped it yet.
So that seems like an opportunity for someone, any of you maybe, to step in and create an award-winning TV show about quantum and why it's so important.
Yeah, it was interesting. I have a colleague who is a video producer with not out of physics background, but he put it really well. He said that a lot of the answers you're looking for, just about the world, about how to make the newest technology, are at this atomic level. So, it's really neat to imagine, learn more about this world. So just in terms of sort of sparking people's curiosity and sort of explaining the profound insights you can get by thinking about the quantum world, I thought was kind of a neat little observation or approach that he had.
To me, probably the hardest barrier that's kind of related to what the two of you have referred to, the hardest barrier to people's curiosity and helping people appreciate how important quantum physics is when I say I'm a quantum physicist, people say, oh, that's hard. So I try to say, it's fun.
Yeah, I think there's a lot of misconceptions about what kind of person you have to be in order to even understand quantum physics at any level. And I think that, you know, to me, I think anyone can really, if you put your mind to it, anyone can really understand quantum physics. So I try to encourage people to, you know, explore that curiosity and not feel like they have to be a certain type of person.
On this social media channels, there's always enthusiasm among our followers for anything quantum. Just bringing up the word will get people excited and interested. There's something about it. So we try to, you know, provide information to them, and so the excitement is not lacking. It's just sort of maybe bringing them into what the quantum world really is.
As to that point, when I was a PhD student at Caltech, sometimes there would be writers from Hollywood who would come to campus as, for instance, a part of the Hollywood Science Exchange. I remember once a writer came to our group meeting and was explaining the kind of the script that he was trying to write and his motivation to coming to a quantum information science group meeting. And he said, quantum has to be in the title of the movie because according to the people in the studios who keep track of these things, if you put quantum in the title of the movie, we'll get this many more likes on Twitter.
Well, yeah, and when you're writing a headline for a story, you look at the, you know, search engine optimization and which keywords have to be in the headline to get, you know, to get it higher up in the rankings. And quantum is definitely, you know, if I'm doing a story with anything quantum in it, we try to, you know, quantum will be in the headline because that is a term that that sparks interest, I think. So, yeah, as you said, Ben.
Yeah, if I could just make one last point, I wanted to just address the question of, you know, some people ask, is quantum overhyped? And I think there's two types of hype. There's one hype about how maybe quantum can help you, like, read someone's mind or something like that. There's sort of that new agey or type of, or crystal hype. But then there's also the hype about the potential application of the technology. And at NIST, we're a government agency, and it's important not to make promises about it that may not come to pass. I mean, it's important that the government spend taxpayer money wisely, and we inform the taxpayers of what the, you know, potential of the technology is. But our releases always contain the caveat, like with quantum computers, if a sufficiently powerful quantum computer were able to break encryption, then X, Y, and Z. So there's always that subjunctive phase we always make sure to put in there. So we want to communicate the excitement, but also, you know, sort of acknowledge the fact that it's not certainty yet.
Yeah, and I would say also in my role as a journalist, that's an important part of the role that journalists play, is that we're, you know, if there's a press release that comes out, you know, not from Ben, but from perhaps, you know, some for-profit company, there's no, you know, if there's no paper behind the press release, or there's no, like, scientific data that's released, or if there maybe is a press release that doesn't say the same things as the scientific paper says, like, these are all kinds of things that I investigate when I'm deciding whether and how to cover a quantum result. So there's an importance in, you know, when you're consuming quantum media, like understanding where it's coming from. Like, are you reading a press release that maybe hasn't been fully vetted? Are you reading a journalist who knows, you know, how to do a deeper dive on the topic and understand if what is being claimed is in fact a reality or if it is hype? So I think, like, having you know, an understanding of where your information is coming from is really important if you're trying to understand the quantum landscape. And that's, you know, one thing that I try to provide as a service to my readers is, like, you know, I have some understanding of these topics. I write about them a lot. I try to, like, follow up with other scientists and confirm whether what's actually being claimed is fact. And there's sometimes debunking that I have to do of, this was claimed and this is not, you know, not, other scientists don't agree. So that's another important part of the process of communicating quantum physics, I think.
Well, thank you, Emily, and we've reached the end of our time. Thanks to all of you for listening. I hope you learned something.